Hey everybody, so I know that the p-value can be pretty tough to calculate, and so I wanted to walk you through a couple of examples. And this is one from the Smart Book where it's asking for a right-tailed test and it gives you the z-score and it's asking you for the p-value. And I'm going to refer to a helpful section of the book on page 336. Of course, it's only helpful if you know exactly what you're looking at, and this part can be pretty tough. And they give you an Excel function right here to obtain what they call the left tail area. And the way that that function works, you see the words, you see like NORM for norm, .s, .dist, and then you'll notice that they put that given z-score, they gave you that 2.152, they put that in parentheses and a comma and a 1. So I am going to use that formula in Excel that they gave me again on that page 336 of the text, and I'm going to type that formula into Excel. So I'm going to go here to Excel, and I am going to copy that generic formula in there, that NORM.S.dist, and then I know it's kind of small on your screen, probably it's a little hard to see, but right up here in the formula box, so it's norm.s.dist, and then you can see in the parentheses that it says z, so I'm going to replace the z with the z-score that was asked of me in the problem, which, as a reminder, was this 1.45. So I'm going to replace that z-score in the Excel formula with a 1.45. So you can see I'm typing in that norm.s.dist for distribution, and then parentheses 1.45 comma 1. Okay, that 1 is part of the formula. I'm going to hit enter, and it gave me a decimal number. So let's make sure we understand exactly what that decimal number means. So recall that the Smart Book told us that this is the formula for the left tail area. So what that means, and I am a horrible artist, so please, please, please forgive me. Yes, I'm going to stink it, even just drawing a normal curve. So because it says the left tail area, that means that is this 0.9264. That is the area of the tail that lies to the left of that particular z-score that we just found. Now, of course, the problem isn't asking me for the area to the left. The problem asked for the right-tailed test. So how are we going to get the area to the right? So I'm going to take that area to the left that I just got from doing the calculation. It does tell us in the text to round to 4 decimal places. So that 0.9264707 that I just got from using Excel, if I'm going to round it to 4 decimal places, that means I'm going to round this digit right here. And remember how rounding works, because the number to the right, that 7, is 5 or bigger. That means I'm going to chop off all this, and I'm going to round that 4 up to a 5. So I took that 0.9265 and I rounded it to 4 decimal places. So again, this represents the rounded area of, so again, that 0.9265 represents that area to the left. So, but what we need to figure out is the area to the right, which means that we're going to have to do one whole and subtract from that the 0.9265, and that will give us the area to the right. If we do that, then we should get the decimal 0.0735. So that will be the area to the right of our z-score. I typed it into the box just to double check and make sure I didn't make any mistakes, and it looks like I got it right. So that is how you would find the area for a right left-tailed test. In this example, it's now asking us for a two-tailed test, but the procedure is still basically the same. So I am going to go back to my Excel. I'm going to use that same formula, except I am going to replace the z-score. I'm going to remove the z-score from the last problem, and I'm going to replace it with the the negative 1.80. So I'm just going to replace the z-score with the z-score for the new problem. And you'll see that now I've gotten a new decimal. So let's make sure we remember exactly what that decimal represents. So because it represents the area to the left of that z-score. First thing I'm going to do actually is I'm going to round, because it does say to round to 4 decimal places. So I'm going to take that decimal, I'm going to round it to 4 decimal places. So that's 0.0359303. And to round it to 4 decimal places, that means I need to look at that 9 and then look at the number next to it. Because the number next to it is smaller than 5, that means we're just going to chop all this off and keep the 9 the same. So remember what that 0.0359 actually represents. It represents the area to the left of that particular z-score. So 0.0359. Now so if it were asking for a left tail test, we would be done. If it were a right tail test it were asking for, then we would have to actually subtract 1 minus this like we did in the previous example, because we're trying to find the area that all lies to that side. But what it's actually asking us for is a two-tailed test. So it's asking us for the area on this side and on this side, because it's asking us for the area within both of those tails. And yes, I realize this is a graph drawing, it is not drawn to scale. So if I've got 0.0359 over here, that means I'll also have 0.0359 over here. So we're just going to combine those two decimals by adding them together. So we can either add them together or just take 0.0359 and multiply it by 2. Either way, we should get the same result, which, if my calculations are correct, is 0.0718. So I will take that 0.0718, double check and make sure, typing it into the box. So I'm going to type it in there, and voila, our answer is correct. I hope that helps to clear up things just a little bit. If it doesn't, by all means, please, please, please let me know. I'll be happy to give you some more examples and some more practice problems, and I'll be talking to you soon.